Hello students, so after understanding how to find out the solution to higher order differential equation, now we are going to start with the type 1 of higher order differential equation, in which we will be having right hand side of the given higher order differential equation as 0. So now I am going to teach you how to find solution of such type of equations. So guys, here you can see one differential equation which is d square y by dx square minus 2 dy by dx minus 4 equal to 0. Now the question is how to find out the solution of this higher order differential equation. Guys, let me tell you, observe the right hand side, because whenever we want to find out the solution of any higher order differential equation, we are going to observe the right hand side, and here the right hand side is 0. Also the left hand side, if you see, it is of the type the higher order differential equation with constant coefficient, because here the coefficient along with dy by dx and d square y by dx square are constant. So guys, here right hand side is 0. Now the question is how to find out the solution of such equation which is having right hand side as 0. So before starting the answer, I'm gonna tell you few steps, and guys, you just have to follow those steps to get the answer. So here are the steps. So whenever your right hand side is 0, what you have to do is you have to first find out the yc, which is nothing but complementary function, and you will find out that yc from f of d equal to 0, which is nothing but auxiliary equation. So guys, for that you first have to find out this f of d. So let's find out f of d, and then let's find out the yc. So what I'm going to do is I'm going to read one step, I'm going to solve that one step so that you'll understand this method very well. So let's find out yc from f of d equal to 0. So now guys, here to get f of d equal to 0, what we have to do is we have to first find out the f of d. So for that we will replace this term d square y by dx square by d square y minus 2, this will be dy minus 4y. So here we have y is equal to 0. Now guys, from this equation I can take y common, so we will get d square minus 2d minus 4 into y equal to 0, and here we get the f of d. So this is of the form f of d into y equal to 0. So this is my f of d. So here I'll say therefore the auxiliary equation So guys, this is the auxiliary equation, and I'm going to find out the roots of this equation. So let's start. So this is a quadratic equation. For quadratic equation, to find out the roots, we have to find out the roots of this minus 4. Now minus 4 is minus 2 into minus 2, minus 2 into plus 2, but we are not getting this term. Or minus 4 is minus 4 into 1. Still we are not getting this term. So we'll find out the roots of this equation by using the formula. So d is given as negative b, so here b is minus 2, so that will become minus minus plus 2, plus or minus root of b square, so square of this is 4, minus 4ac, so a is 1 and c is negative 4, upon 2a, so 2 and a is 1. Now this is minus 4 into 1, minus 4 into minus 4, that is positive 16, plus 4 is 20, so that becomes root 20. So here we'll get d equal to 2 plus or minus square root of 20 by 2. Now guys, square root of 20 is nothing but 4 into 5, and the root of 4 is 2, so I can say that this is nothing but 2 plus or minus 2 root 5 by 2, and if we cancel this 2 from numerator and denominator, we get it is equal to 1 plus or minus root 5. So now guys, we are getting roots as 1 plus root 5 and 1 minus root 5, and let me tell you that this is real and irrational root. So we are going to find out yc for this root by using the method of real and irrational roots. So here on the screen you can see the method or the roots of the given equation, and if let's say the given equation is having the roots as real and irrational, here you can see how to find out the solution of such equation. So yc is e to the power this a term which is not inside the root, so that is e to the power ax, and this root b, that will be angle of hyperbolic cos and hyperbolic sine. So here we'll say that therefore this yc is equal to e to the power 1x, that is x, inside the bracket c1 hyperbolic cos of root 5x plus c2 hyperbolic sine of root 5x. So guys, this is the value of yc. So for the given question, we got yc, and here we have completed the step number 1. So step number 1 is completed, that is finding the yc. So we got yc. Now the step number 2 is find yp. So yp is 1 upon f of t into x, where x is the right hand side of higher order differential equation. But guys, let me tell you that right hand side is 0. So since it is 0, 1 upon f of t into 0 will be 0. It means yp is 0. And guys, therefore y is yc plus yp, that is complementary function plus particular integral, and since yp is 0, our y will be yc. So remember one thing, that whenever we have the differential equation with right hand side equal to 0, that time our complementary function is the complete solution of that given higher order differential equation. So guys, yc is the solution of that given equation. So here I'll write that y is equal to yc plus yp, and yp is 0, so which is equal to yc plus 0, which is equal to yc. So guys, therefore the value of y is equal to yc. I'll copy down this value, and that is the final answer. So guys, this is how we find out the roots of equation or the solution of the given higher order differential equation when right hand side is equal to 0. So I'm sure that you understood the method, and in the coming videos I'm gonna cover a few more numericals in which the right hand side will be 0. So guys, don't forget to subscribe to Ekeeda channel, because here I and the other faculties are taking efforts to make the videos for such a wonderful crowd like you, and we want to spread this education to whole world. So don't forget to share this video with your friends, because they can also subscribe to the channel and they can also enjoy these videos from us. So thank you very much. See you everyone in the next video.